So till now, we have completed students' first experiment, second experiment, and third experiment, right? And we conducted the assessment of all the three experiments, right? So we have not started experiment 4, right? In your lab. It is started or not started?
मैम सिर्फ ब्रीफली बताया था,
Huh?
सिर्फ ऊपर ऊपर से बता दिया था कि क्या करेंगे.
Yes, so today we will start our experiment number 4 of EWP Lab, right? So all of you able to see the screen? Lab manual?
Yes, ma'am.
Right. So this is the experiment number 4. The aim of this experiment is to identify the various electronic components and their applications and the demonstration of various electronic components, right? So here we will be going to discuss various electronic equipments like diodes, transistors, ICs, right? So all these things we will discuss. So we will see how they work, how to identify these components, and how we can do the testing of these components, right? So in the first experiment, you already studied symbols of various uh, components or various devices used in electrical engineering, right? Also, you have learned about, means you know some symbols of electronic components, right? Like diode, okay, like transistor. So these things, you know, so here we are going to discuss basically diodes, transistors, the ICs, their applications. I will demonstrate you the components and the testing of the components using multimeter, right? Okay, I think in your lab transistors are finished, right? We discussed transistors. Yes or no? Right, diodes are discussed, right? Okay. The testing of diode video is shown to you.
यस मैम, वो ट्रांजिस्टर से स्टार्ट करना मैम, वो बाइपोलर जंक्शन ट्रांजिस्टर.
We will discuss today transistors testing, right?
यस मैम.
So basically we will discuss the transistor here because diodes are already discussed as you are seeing that. So transistor is transfer of resistance, right? Transistor word comes from the two things, transfer of resistance, right? So there are, basically it is used for the, to control the current and for the switching, right? So here are two categories. One is BJT, another is FET, right? So basically, in this experiment, we will talk more about BJTs, right? So FETs, again, we have different type of FETs, like FET is called field effect transistor, right? So it can be of JFET, junction field effect transistor, MOSFET, MOSFET, metal oxide semiconductor field effect transistor. Now in BJT, we have again two types of transistor. We have PNP and we have NPN, right? So in transistor, we have three layers, okay, and two junctions. Whereas in diode, we have one junction and two layers, right? In transistor, we have three layers and two junctions. So three terminals are there. Okay. So what are these three terminals? Emitter. We are talking about BJT first, right? Emitter, base, and collector. Okay. So we have two type of transistor in BJT, PNP and NPN. So construction of transistor will be like this. In PNP, we will have two layers, P and P, right? Two layers of P and one is N, P and P. So emitter is, this is emitter, P type, base is N type, collector is P type, right? In NPN, we again have three terminals, emitter E, base B, collector C. So now here emitter and collector are of N type, right? Okay, any doubt in this? Now you can observe here, students, there are two layers. There are three layers of material like P and C, right? And there are two junctions. One is between emitter base, one is between base collector, right? Can you observe this thing? Okay. Now we are talking about the symbol. So symbol of transistor is like this. Okay, so this is the symbol. So this is the BJT transistor symbol. Now, how you will identify if it is PNP or NPN? So there is one arrow also present like this, right? So if this arrow is inward in inner direction, so it is a PNP transistor, right? And if this arrow is outward direction, so this will be NP. This will be an NPN transistor, right? Like this. So this direction of arrow shows the direction of the emitter current, i.e. emitter current, right? Okay. So now we'll see in detail how this PNP works. So as you know, we already discussed this thing that this is suppose PNP. Okay. So this transistor in this transistor will be connected by two sources. Okay. Two sources will be there. So one is between the collector base, right? This is emitter base collector, right? And one is between the base emitter, right? You will connect two sources. So the two junctions, one will be forward bias, another will be reverse bias. So always this emitter base junction is forward bias, right? So the depletion layer here will be less. And here the depletion layer is more because this is reverse bias. This is emitter, base, collector, P, N, P, right? So this is depletion layer is width is more, right? Because this junction will be forward bias, this will be reverse bias, right? Any doubt in this? Any doubt, students?
No, ma'am.
Now if you connect, means how you will make this forward bias, reverse bias, you need to connect the battery in that way. Okay, so we'll connect here one battery. Okay, so the battery positive terminal will be connected to P and negative will be connected to N. Then only you can say that it is forward bias. Okay, now here one more battery will connect. Okay, so now you can see this junction we need to reverse bias. So this N type will be connected to positive and this P type will be connected to negative. His base is connected to positive and collector connected to negative. Then only we can say this is reverse bias junction. Right? Understood, students? Okay. Again, if you have NPN transistor, so same thing you need to do. This is NPN, right? So this part, middle one is base, this is emitter, collector, right? Now this, I need to make this junction between base and emitter as forward and collector base as reverse. So what will happen? This layer will be, depletion layer will be less, means there is width is less, and this layer will be more because this is reverse bias junction. So how will I connect the battery here now? So this is N type, so I need to make it forward bias junction. So here I will connect negative and here I will connect the positive. Okay, then also here This is N type, this is P type. So this should be reverse bias junction. So here I will connect like negative and positive, right? Understood? Understood, students?
Yes, ma'am.
Okay. So now how it will work? This, suppose we are taking PNP example. Okay. So how it will work? Okay. So first of all, this junction is forward bias. So what will happen? Here in we call this type of transistor as BJT. Why we call BJT? Bipolar junction transistor, because here the current flows means bipolar, means with the with both the majority charge carriers, right? So here in P side, what will happen? Positive holes will be the majority charge carriers, right? Yes or no? Yes or no? And in N, you have the electrons as majority charge carriers, right? So, but as compared to P layer, the electrons and means the holes are more and electrons are less. Why? Because this base is lightly doped, as you know. Emitter is heavily doped, right? Okay, so when you're providing the here the you will connect the source, so this junction will be forward bias. So what will happen? This hole try to move toward electrons, means base, and this electron will try to move towards the P, their emitter, right? So they will combine, but there are more holes, so they will travel to the base, to the collector, right? So current will flow through because of these holes from emitter to base. That is emitter current, right? So that's why we took the, in the symbol, we took the inverse direction of current when we are considering the PNP, because in this emitter current is towards the base, right? Like this. Okay. Okay, students, any doubt? And these holes will travel here till the collector, so the collector current will also flow, right? And if we are considering the NPN transistor, so what will happen? The direction of current will be opposite, okay? So that's why we are considering the emitter current direction outward, okay? Okay, students? Now, if you want to test a BJT, that is bipolar junction transistor, so suppose you have a transistor BJT and you don't know which terminal is base emitter collector, right? And you also don't know if this is PNP or NPN. So how you will check, how you will test? So you can test using multimeter, right? So first of all, I will show you how the transistor looks like. Then we'll see how to test the transistor. So students, you can see this is BJT, the bipolar junction transistor. So in this, we don't know which terminal is. Three terminals are there: T1, T2, T3, suppose. But we don't know which one is base, which one is emitter, which one is collector, and whether this transistor is PNP or NPN. So how to test these all things: base, emitter, collector, terminals, how to identify these terminals, and how to identify if it is PNP or NPN, right? So I will share one video. You first see that video, then we will discuss your doubts. So here the link is shared with you students. In chat box you can see the link and you can access this link. And check, tell me whether you are able to access or not. And this is approximately 9 minutes video. So after that, after this 9-10 minutes, we will discuss your doubts. So please watch the video. Okay, students, please watch the video.
Yes, ma'am.
Hi, in this video I'm going to show you how to test a transistor using a digital multimeter. So before we do that, I'm going to show you how to test a diode. So this is a typical construction of a diode, which basically consists of two layers of semiconductor and sandwiched together, which is a p-type and n-type. So when we apply a positive voltage here and a negative voltage here, a current will start flowing, as we call a forward bias. And if we connect the other way around, positive here and a negative voltage here, the current will not flow. This is called reverse bias. So in forward bias, which we were using during testing, when it's in forward bias, let's say we supply 3 volts, when current starts flowing, there will be a diode drop or voltage drop, or another thing like it's called a forward bias voltage. And to measure that, it's actually quite easy. So you just take your multimeter and place a probe on the diode pin, and then you will get the reading for the voltage drop across the diode. In this case, like silicon diode, you will get pretty much close to 0.7 volts. Now let's move to the transistors. So transistors basically consist of 3 layers of semiconductors. They are sandwiched together, and it looks like a diode being placed back to back. So we can do the same thing the way we test diode. So to identify which one's PNP or NPN, we simply place a probe. We need to test which pin is actually conducting. So let's, for example, like we place a positive probe here and a negative probe here, or ground probe, and then once we place it there, we will get a reading, which means the current is flowing. And also, when using a digital multimeter, make sure it's in diode setting. So on the probe, there's actually a voltage being supplied as well. So when you place your probe on a positive or a p-type and n-type, which means it's now in forward bias, and you will get the voltage drop on the meter based on across here, which is the voltage drop across the p-n junction here. So and when we get to find another pin like this one, if we place another probe here, we also get a voltage reading on the digital multimeter, which means we know that these 2 pins are p-type and the center one is n-type. Then we also know that this black probe here, which is doesn't move, only this probe is moving. We know that this pin is base pin, and the same thing we do at the NPN. We simply probe in which one we have a current flow. If we have a current flow, let's say we put it in this way, so we know this voltage reading, then we know this one is p-type, this pin is n-type. So when we move the other way around, we also get a reading, which means this one is NPN, since the only negative probe is moving and the only one pin stays on positive probe, which means it's p-type, so we know it's NPN. So how do we know which one is the emitter and collectors? It's actually quite easy, and when we measure it, let's say this pin right here, we will get a forward voltage reading, or I mean a voltage drop actually. It's a voltage drop reading about 0.666, and on this pin we will get somewhere 0.669. The value is actually not really large, but there's significant changes in there. So now we know that the highest voltage drop across it is will be called the emitter, and this one is the collector pin, and this one of course the base pin. The reason that this p-n junction on the base emitter, because the p-type on the emitter is heavily doped with impurities, that's why it has greater voltage drop compared to a collector base junction. Okay, so that's how you identify which pin is emitter and collector. Same thing as the NPN type. So let's try one. Let's test. So I'm going to use normal transistors here. I'm going to tell you which part it is. Probably see the label there. So set the multimeter to a diode setting, and then I should place it right here. There you go. So we have 3 pins. I need to make it maybe too close. Okay. So let's test one. So when I apply center pin and with the ground probe and a positive probe, we got a forward bias voltage. And when I move this probe around, nothing happened. So which means that's not the right pin. So we move this probe around, we also get a reading. So we know we only move one probe here. So which means this probe is p-type. N-type. So this one is p-type because it's a positive probe. So this is p and p. So how do we know which one base collector emitter? Well, this probe here, the ground probe, is basically the base. And if we take a look at the multimeter, this pin is 708, and this pin is 712. So we know that this one is the emitter pin, this one is the collector pin, and that's how you identify transistor pins. So let's try other transistors. I'll put this one on the breadboard. Hang on. I have another transistor here, so let's try probing. So let's try the same way. Do we get the same reading? Nope. Let's put this one. Nope. So let's try the other way around. There you go. We got a forward bias voltage. Now let's move this probe around on this side. We also get a reading. So now we know that this pin is p-type and this one is n-type on this side. So we know that it is an NPN transistor since it's a negative probe here. So which one is base collector emitter? This one's the base because it's the only probe it doesn't move. So this one is 661. This one is 6. Oh, sorry. This one is in 660. 661. 660. So we know that this one is the emitter pin. This one is the collector pin because the forward voltage drop across this pin is higher than this one. And that's how you identify transistors and which pin is base collector and emitter. And that's all for today. And don't forget to subscribe for more future videos.
Welcome to CB Electronics. Friends, today we will discuss how to check transistor.
multimeter one terminal you need to keep on terminal 1, right? And other terminal of multimeter you need to keep on both one by one at terminal 2 and at terminal 3. So you will be measuring the resistance between terminal 1 and 2 and terminal 1 and 3, right? Terminal 1 is common for in first case, right? So if you are getting high low, low high, so it cannot be a base, right? Either if you will get high low, 1 2 is high, or 1 1 3 is high, or T1 3 is low, or T1 2 is low. Means you will get one combination as high and one combination as low, so it cannot be a base. So to means to be if a terminal is base, so it there should be the same resistance between all the terminals, right? So suppose you are taking T2, now you fix T2 terminal of multimeter, you fixed at T2, and you are measuring the resistances between terminal 1 and 3, this means T2 with T1 and T2 with T3, right? So again you are getting high low either or low high, so it cannot be a base, right? So if you are measuring now you are taking T3 as common terminal and you are measuring the 1 and 2 terminal resistance with respect to 3, so you will get either high or low, right? So if you are getting this case high or low, so T3 can be a base, right? So now it can be a base, but need to confirm if it is base or not. So what we will do to confirm it is base. So suppose you are getting high result, right? T31 is high, T32 is high, right? So to confirm the base, reverse the connection of the multimeter. So after reversing the connection, the result will be low, right? Both will be low, T31 and T32. So that confirms that it is T3 is base, right? So now if you know the base, you can check emitter and collector, right? Right? So how, and you can also identify if it is NPN and PNP, right? So once the base is fixed, measure the resistance between base and other two terminal, right? तो T3 तो फिक्स हो गया, आपका बेस है, तो T3 के साथ में अब आपको T1 और T2 का रेजिस्टेंस मेजर करना है, right? So the lower resistance indicates the collector terminal and the higher resistance indicates the emitter, right? To identify the type of transistor, if you want to identify transistor as NPN or PNP, so keep positive terminal of multimeter on base and negative terminal on remaining two terminals one by one and measure resistance, right? If meter indicates low resistance at both the terminals, right? So the transistor is NPN because positive terminal on base and negative terminal of multimeter battery on emitter collector forward bias the junction, so the multimeter indicates low resistance, right? If meter indicates high resistance at both the terminal, the transistor is PNP because positive terminal on base and negative terminal of meter battery on emitter collector reverse bias the junction. तो द मल्टीमीटर जैसे हमने डायोड के लिए चेक किया था, लाइक दैट, कि अगर लो रेजिस्टेंस आ रहा है तो फॉरवर्ड बायस जंक्शन है और हाई रेजिस्टेंस आ रहा है तो रिवर्स बायस जंक्शन है, तो पोलैरिटी आप चेक कर सकते हो, ठीक है? अंडरस्टूड स्टूडेंट्स?
मैम इसमें एक बार मल्टीमीटर वाले कनेक्शन में बता सकते हैं क्या? उस वीडियो में नहीं बता रखे थे कनेक्शन मल्टीमीटर से।
वो आपको जब डायोड का वीडियो दिखाया था तब मैंने बताया था, लेकिन मैं फिर से बता देती हूँ एक बार, ठीक है? अब आप लोग याद नहीं रखते हो तो प्रॉब्लम हो जाती है फिर। अभी लास्ट टर्न पे ही मैंने डायोड का ये बताया था, पूरा डायोड के बारे में पूरा मल्टीमीटर समझाया था। तो ये आपका मल्टीमीटर है सपोज, ठीक है? अब यहाँ पे कनेक्टिंग 3 टर्मिनल्स होते हैं, एक पे ऐसे करंट रहता है, एक पे वोल्टेज और एक कॉम रहता है, कॉम, राइट? आपके पास 2 प्रोब होते हैं, सॉरी एक प्रोब होता है आपके पास, उसमें 2 वायर्स, एक तो रेड वायर और एक ब्लैक वायर, ठीक है। अब ये इस प्रोब को आपको, जो ब्लैक वाला है वो आपको कॉम कॉम मतलब कि ये ग्राउंडेड रहता है, ये नेगेटिव है पोलैरिटी इसकी, ठीक है। ये नेगेटिव, ये मल्टीमीटर का नेगेटिव है, आप मान लीजिए, ठीक है। तो आप ब्लैक वाला इस पे कनेक्ट करते हो और जो रेड वाला है वो आप यहाँ कनेक्ट कर दोगे। तो अब ये तो है पॉजिटिव और ये है नेगेटिव, ठीक है। तो अब जब आपको कोई भी जंक्शन चेक करना है, मान लो डायोड चेक करना था आपको, पीएन जंक्शन था, तो जब आप इस पॉजिटिव को यहाँ लगाते हो, ठीक है, पता नहीं है मुझे अभी ये पीएन कौन, पी साइड कौन सा है, एन साइड कौन सा है, अभी पता नहीं है मान लीजिए, ठीक है। आई डोंट नो इट इज पी साइड और एन साइड, ठीक है, कुछ भी हो सकता है, मुझे तो टेस्ट करना है पहले। तो मैंने यहाँ कनेक्ट किया है ये, ठीक है। मतलब मैंने पॉजिटिव वाला जो था इधर, ये बैटरी, ये मल्टीमीटर की बैटरी का पॉजिटिव मैंने यहाँ कनेक्ट कर दिया डायोड में, और नेगेटिव ऑफ मल्टीमीटर मैंने यहाँ कनेक्ट कर दिया, ठीक है। आप इसको बैटरी मान लीजिए, ये जो वायर्स है। अब अगर आपको रेजिस्टेंस हाई मिलता है, मल्टीमीटर में जो रीडिंग आ रही है वो हाई रेजिस्टेंस आ रही है, ठीक है, इसका मतलब क्या हुआ, हाई रेजिस्टेंस कब मिलेगा, रिवर्स बायस में मिलेगा या नहीं? यस और नो? यस और नो? रिवर्स बायस में क्या होगा, जंक्शन रिवर्स बायस है तो वो करंट फ्लो नहीं होने देगा ना, मतलब हाई रेजिस्टेंस ऑफर करेगा। तो यहाँ पे आपको हाई रेजिस्टेंस शो हो रहा है, तो इसका मतलब कि ये आपने जो कनेक्शन किए हैं उस कनेक्शन से रिवर्स बायस है जंक्शन, मतलब ये पॉजिटिव नेगेटिव कनेक्ट करने से रिवर्स बायस हो गया। तो इसका मतलब क्या हुआ, ये पॉजिटिव यहाँ कनेक्ट था, तो ये कौन सी साइड होगी, दिस साइड विल बी
P.
ये पॉजिटिव है, अगर ये बैटरी का पॉजिटिव है तो ये कौन से साइड होगी, रिवर्स में आने के लिए, हाँ।
P होगी ना।
पी क्यों होगी, फॉरवर्ड बाय रिवर्स बायस कब होता है, कुछ याद नहीं रहता आप लोगों को, है। ये देखो, जब बैटरी का पॉजिटिव आप पी से कनेक्ट करते हो तो क्या होता है, फॉरवर्ड बायस होता है ना। और जब
हाँ यस।
बैटरी का नेगेटिव आप कनेक्ट करोगे पी से, तब ये रिवर्स बायस होता है।
रिवर्स बायस यस।
तो फिर अभी ये रिवर्स बायस है, ये बैटरी का पॉजिटिव है, तो ये कौन सा होगा,
N. N.
एन। और ये कौन सा होगा,
P.
समझ में आ गया?
यस मैम।
यस मैम।
यस मैम उस दिन भी बोल रहे थे, फिर क्या समझ में आया जब डायोड ही नहीं आया समझ में? तो मान लीजिए यहाँ पे लो रेजिस्टेंस शो हो रहा है, मैंने ऐसे ही कनेक्शन किया है, लो रेजिस्टेंस शो हो रहा है, तो फिर ये कौन सा होगा, पढ़ के नहीं आते हो आप लोग बिल्कुल भी, एक्सपेरिमेंट
फॉरवर्ड
में बोला
बायस।
है कि पढ़ के आया करो।
फॉरवर्ड बायस होगा, लो रेजिस्टेंस आएगा तो।
हाँ, लो रेजिस्टेंस आएगा तो ये फॉरवर्ड होगा, फॉरवर्ड मतलब ये पॉजिटिव था तो यहाँ पे पी होना चाहिए, समझ में आ रहा है, और ये एन होना चाहिए, ठीक है। तो इसी तरह से ट्रांजिस्टर में भी चेक करना है, पी एन पी, 3 टर्मिनल है, मुझे नहीं पता पी एन पी है या एन पी एन। मैंने मल्टीमीटर एक तो बेस पे लगाया टर्मिनल, ठीक है, बेस पे मैंने कौन सा टर्मिनल लगाया मल्टीमीटर का, सपोज मैंने पॉजिटिव वाला यहाँ बेस पे फिक्स कर दिया, ठीक है, और जो ये नेगेटिव है मल्टीमीटर का वो मैंने यहाँ पे पहले लगाया। फर्स्ट ये टर्मिनल T1 है, ये T2 है, ये T3 है, ठीक है। T1 पे मैंने लगाया तो मुझे यहाँ पे अगर हाई रेजिस्टेंस मिल रहा है, इसका मतलब क्या हुआ, ये P होगा या N होगा एमीटर, ये T1 टर्मिनल कौन सा होगा? अरे ये यहाँ पे कनेक्ट कर दिया, ये नेगेटिव है ना, ये मीटर बैटरी का, इसको बैटरी समझ लो ना आप मल्टीमीटर को। ये नेगेटिव है, ये पॉजिटिव है बैटरी का। अब मैंने इस तरह से कनेक्ट किया है और अगर ये हाई रेजिस्टेंस आ रहा है, इसका मतलब क्या हुआ, ये P होगा या N होगा?
एन होगा, रिवर्स बायस होगा अगर अपन
एन
देखें तो
एन
एन होगा।
तो N क्यों होगा? फिर से वही गलती कर रहा हूँ।
P होगा ना, क्योंकि रिवर्स बायस है और नेगेटिव है तो फिर P।
रिवर्स में तो ये पॉजिटिव से कनेक्ट रहता है ना N।
जो पॉजिटिव वाला कनेक्टेड है वो एन होगा, जो बीच वाला है T2।
तो ये नेगेटिव है तो ये क्या होना चाहिए, P होना चाहिए।
हाँ मैम, T1 P होगा और T2 N होगा।
T2 एन होगा।
हाँ तो ये PNP हो गया ना।
यस मैम।
समझ में आया?
यस मैम।
तो अभी दोबारा से वीडियो देख लो एक बार, अब समझ में आ जाना चाहिए आई थिंक। Okay, done, students?
Yes, ma'am.
Now any doubt?
No, ma'am.
सारा समझ में आ गया? कैसे एनपीएन पीएनपी पता चलेगा और एमीटर बेस कलेक्टर कैसे पता चलेगा?
Yes, ma'am.
Yes, ma'am.
ओके, तो ये टेबल आपको ध्यान में रखना है, ठीक है? तो ये T3 पे हमने देखा कि अगर हाई हाई या लो लो मिल रहा है रेजिस्टेंस विथ रिस्पेक्ट टू 1 एंड 2, तभी हम उसको बेस समझ सकते हैं। ऐसा क्यों? दोनों सेम मिलने पे क्यों? बाकी दो केसेस के लिए क्यों नहीं बेस हो सकता? हाई लो या लो हाई पे क्यों नहीं हो सकता बेस? यस, एनी आंसर?
मैम क्योंकि फिर अगर बेस लो होगा तो फिर 2 लो हो जाए। नहीं वो नहीं।
हाँ, बताओ क्यों नहीं हो सकता? क्यों दोनों सेम ही क्यों? हाई हाई या लो लो पे ही क्यों बेस हम आइडेंटिफाई कर रहे हैं? समझ में आ गया ना आपको? तो बताओ। देखो ये है आपके पास में पीएनपी, ठीक है, या फिर आपके पास एनपीएन, जो भी है, ठीक है। इसमें जो ये वाला टर्मिनल है, ये सपोज आपको पता है बेस है ये, ठीक है। मतलब कोई भी पीएनपी या एनपीएन ट्रांजिस्टर होगा तो उसमें एमीटर कलेक्टर तो सेम मटेरियल के है ना। अगर पीएनपी है तो दोनों पी टाइप के एमीटर कलेक्टर, ठीक है। अगर एनपीएन है तो भी एमीटर कलेक्टर सेम मटेरियल है, एन एन, राइट? यस और नो? एमीटर कलेक्टर तो सेम मटेरियल के ही है ना।
हाँ
या तो एन एन होंगे दोनों, या तो पी पी होंगे, राइट?
Yes, ma'am.
तो अगर आप जब भी आप मान लीजिए बेस पे मैंने ये आपका जो है पॉजिटिव टर्मिनल ऑफ मल्टीमीटर, मान लीजिए नेगेटिव टर्मिनल ऑफ मल्टीमीटर रख दिया यहाँ पे, ठीक है। नेगेटिव वाला यहाँ पे टच कर दिया। अब ये जो पॉजिटिव वाला है मल्टीमीटर का, ये मैं एक बार तो ये टर्मिनल 1 पे चेक करूंगी और दूसरे बार टर्मिनल 2 पे एक बार चेक करूंगी, ठीक है। तो विथ रिस्पेक्ट टू बेस T1 और T2 चेक करना है, मतलब ये T3 के रिस्पेक्ट में T1 T2 चेक कर रहे हैं, ठीक है। तो दोनों या तो फॉरवर्ड बायस आएंगे या तो रिवर्स बायस आएंगे, क्योंकि दोनों पी टाइप है ना। समझ में आ रहा है?
Yes, ma'am.
तो अभी इस केस में जो मैंने अभी किया हुआ है, ये पॉजिटिव वाला इधर पी पे रखा है और ये नेगेटिव वाला एन पे, ठीक है। तो अभी इस केस में लो मिलेगा रेजिस्टेंस या हाई मिलेगा?
Low.
ये नेगेटिव है और ये पॉजिटिव है पी टाइप, ठीक है। तो आपने नेगेटिव नेगेटिव, तो यहाँ पे आपको फॉरवर्ड बायस यानी लो रेजिस्टेंस मिलेगा, ठीक है। तो सिमिलरली जब आप इस वाले को पॉजिटिव को अब आपको क्या करना है, हटा के अब किस पे लेना है, यहाँ पे किस पे टच करना है आपको, इसको कनेक्ट किस पे करोगे? आप कलेक्टर पे करोगे, इसको हटाना नहीं है, T3 से हटाना नहीं है, दूसरे वाले को चेंज करना है, ठीक है, अब आपने T2 पे कनेक्ट किया तब भी तो आपको लो ही मिलेगा ना। अगर ये बेस है तो ये दोनों पे आप जब भी इसको कनेक्ट करोगे तो या तो लो लो रेजिस्टेंस मिलेगा या हाई हाई मिलेगा। समझ में आ रहा है?
यस मैम।
तो ये लो लो मिल गया इस केस में। और अगर ये NPN होता तब आप ऐसा करते कि यहाँ पे आप फिक्स करते मल्टीमीटर और दूसरा यहाँ पे फिक्स करते तो आपको क्या मिलता रेजिस्टेंस?
मिलता अगर वो पॉजिटिव और वो नेगेटिव है तो।
हाई हाई मिलता ना। एक बार इस पे किया तो हाई मिलेगा, फिर आपने यहाँ पे कलेक्टर पे किया तो भी हाई मिलेगा। यस और नो?
यस मैम।
तो इसका मतलब जब आप इसका मतलब कि ये बेस हो सकता है क्योंकि बेस के रिस्पेक्ट में ही आपको हाई हाई या लो लो रेजिस्टेंस मिलेगा। ठीक है, इसका मतलब ये T3 क्या हो सकता है, बेस हो सकता है। आपने चेक कर लिया एक बार, इस पे नेगेटिव रख के पॉजिटिव चेंज करके भी देख लिया, एक बार नेगेटिव फिक्स करके और पॉजिटिव फिक्स करके नेगेटिव चेंज करके देख लिया, तो आपको क्या मिल रहा है, हाई हाई लो लो। तो इसका मतलब क्या हुआ कि ये टर्मिनल आपका बेस है। बेस के ही उसमें जब आपका बेस होगा तभी आपको सेम रेजिस्टेंस पाथ मिलेंगे। समझ में आ रहा है सभी को?
यस मैम।
क्योंकि एमिटर और कलेक्टर जो है वो सेम टाइप के मटेरियल, बेस अलग टाइप का मटेरियल, बेस हमेशा अलग मटेरियल होगा, कलेक्टर एमिटर हमेशा सेम टाइप होगा, PIN। Now I hope you understood all the things. Okay. So now BJT testing we have completed, diode testing we have completed. So almost diode, transistors, the ICs, PCB, all things are covered now, right? So this experiment 4 is completed. So now we'll go through the experiment number 5, right? Okay. So this experiment is completed. Now we are discussing here experiment number 5. So the aim of this experiment 5 is soldering and resoldering techniques. Okay. And the second aim is implementation of small circuit based minor project. ठीक है, तो आपको ऑफलाइन लैब होती है तो आपको ये इम्प्लीमेंट करना है सर्किट, मतलब सोल्डरिंग करना है PCB पे, बट अभी ऑफलाइन लैब नहीं है, ऑनलाइन लैब है, तो आपको मैं एक सर्किट दूंगी, वो आपको सर्किट डायग्राम बनाना है एंड उसके कंपोनेंट्स की डिटेल्स लिखनी है, राइट? तो पहले हम एम ए देख लेते हैं, व्हाट इज सोल्डरिंग एंड डिसोल्डरिंग टेक्निक्स, राइट? So as you know what is soldering, so can you define the soldering? What is soldering? Soldering आपने सुना है ना वर्ड?
मेल्ट करके कोई नए शेप में कुछ बनाना,
क्या बनाना?
इक्विपमेंट्स।
सोल्डरिंग कहाँ पे की जाती है और क्यों की जाती है? What is the purpose of- So if you want to join any two electrical parts, you can, soldering is the process by which you can join the two electrical parts, or you can means install your components on the PCBs. If you are making an electronic circuit, so you can fix the components on PCB, connect the components on PCB, right? Using the soldering process. So in soldering, what things we require to do any soldering? So first of all, we need a soldering device, means a machine that is known as soldering iron, right? Then we need a solder material, means a material which is made of tin and lead, mixture of tin and lead, right? That is called solder. So without solder and soldering machine, that is soldering iron, you cannot do the soldering, right? So let me show you all the things first. So you can see, student, this is the soldering iron, right? This is called soldering iron, right? You need to plug this into power supply, right? And then this is the tip of this soldering iron, and the temperature of the tip is about 400 degrees centigrade, right? So you can solder the parts, you can join the parts, right? Electrical parts, or you can join the components to the PCB. Okay, it seal the gap between that. So means it seal the joints, right? So this is soldering iron, the machine through which we can do the soldering. Now the other thing you require is the solder. Solder this is the solder. Okay, this one is the solder wire, right? And it is made of mixture of tin, lead and tin. Okay, so in this second figure, this is first figure, solder. This is second figure. You can see how we can apply this solder. Now we can do the soldering, right? So we apply solder here, and this is soldering machine, that is soldering iron, and it is heating the solder and sealing the joints. So this is the fume, and this is very dangerous fume because this wire is made of lead and tin. Lead is a poisonous material, so you need to take care while soldering. You need to take care of your eyes, and it is also harmful for your lungs, right? Because this fumes. Right? Understood, students? So while doing the soldering, you need to take care of some things, that the tip of means this soldering iron is very the temperature is very high of the tip and this iron. So what you need to do whenever you have means as soon as you completed your soldering, you need to just put this soldering iron into the holder, into its holder, right? Okay, so that means it is safe to keep it in holder. Okay, because if you keep this soldering iron at any other surface, it will burn up, right? So keep it in holder only, and switch off the supply. Okay, when you are not using this iron, switch off the supply. Then another thing is that you need to take care of the amount of this solder wire that you are applying on your soldering. So it cannot be too much and it cannot be less. Okay, it should be in appropriate quantity, because if you apply too much solder, so it is a wastage, and also your joint will be very wide joints will be there. Okay, very heavy joints will be there. So whenever you are connecting the components on PCB, so what will happen, there is a limited space to connect. Sometimes there is a limited space to connect between two components. So what will happen if your joint is like this much big, if you apply more means too much solder, so joint will be like this. So when you are joining the adjacent component, so its joints will be more, so these two joints will will be in the contact, and it may possible there will be the short circuit in your board, right? Understood, students?
Yes.
So the how much wire is required, of what quantity, so that comes with the practice. Okay, if you practice, you will see that means you will get an idea that how much solder you need to apply, right? And if you are using very less solder, so it may possible that your joints are not proper and the components are not fixed properly. So then you need to rejoin. Means you need to do again. You need to desolder and you need to rejoin it. Okay, so it will be a loose or we can say weak joint, right? So first of all, soldering techniques. So the most fundamental skill needed to assemble an electronic project is that of soldering, right? If you want to design any electronic circuit, so you should know how to do soldering. Without soldering, you cannot make your electronic circuit, right? Any project is 1 minute. Okay, so the most fundamental skill needed to assemble any project is that of soldering. So soldering is the process of joining two metals by the use of a solder alloy made by combining tin and lead in different proportions. Okay, so it takes some practice to make the perfect join, but the idea is simple: to join electrical parts together to form an electrical connection using a molten mixture of lead and tin, that is called solder, with a soldering iron, right? And this is the soldering iron. Now there are a few important factors of this soldering iron: the voltage, the wattage, the temperature control. Okay. So what is the voltage factor? Means, so most of the soldering iron runs from the main supply, that is 240 volt main single phase supply coming to the switchboard. We can run our soldering iron through this supply. However, there are low voltage soldering irons are also available, that is 12 volt and 24 volt, but they are generally the part of soldering station. Okay, if you want to use these low voltage type soldering iron, so it comes with the soldering station. So now we will show, means I will show you what is soldering station. So okay, so another factor is wattage, means the power consumption. Okay, so typically they may have a power rating between 15 to 25 watts. Normal soldering iron that we use normally having the rating of 15 to 25 watts or so, but it is fine for most of the works. But higher wattage irons are also available, and but that doesn't mean it runs hotter. It simply means that there is more power in reserve for coping with large joints, right? Then temperature control. So the simple and the cheapest irons doesn't have any temperature regulation, right? So you need to simply plug them in and switch them on. So thermal regulation is designed with some expensive irons, right? So mostly people use unregulated irons, general purpose iron. Now soldering station, just a minute. Okay, students, you can see these are the soldering stations, right? So actually there is a soldering iron. This is one model, right? This is one model. This is another model. There are two models I have shown here. This is model number 2. This is model number 1, right? There are many models are available. Okay, so here you can see this is soldering station. So in this station, this is a whole setup, right? So there is a holder to hold this soldering iron. This is soldering iron, right? And this is the control box, right? It's a control unit of this. So it provides the regulation temperature. Okay. So this whole setup is known as soldering station, right? Understood, students?
Yes, ma'am.
Now, next thing is these thermal bits, right? So these are called thermal bits. Okay. These are thermal bits. Means you can connect any type of bits to here in your soldering iron. What type of means whatever type of work you want to perform. If suppose it is micro electronic use, right? So there are very small components, very small thin joints, right? Very small joints are there, so you need to select bit accordingly, right? Tip of this soldering iron, right? Another type of machine to do soldering is the soldering gun. Okay, soldering gun. So its shape is like pistol. This is the soldering gun, right? Soldering gun. It's pistol shaped soldering machine, right? So it takes high power, means high power consumption is there, approximately 100 watts, right? But what happens, it is heavy in, means heavier in weight. Okay, and we cannot use this gun for the microelectronics use, right? माइक्रो इलेक्ट्रॉनिक्स में आप यूज नहीं कर सकते बिकॉज वहाँ पे बहुत छोटे कंपोनेंट्स हैं, आपको बहुत छोटे छोटे जॉइंट्स हैं, वहाँ पे आपको सोल्डरिंग गन का यूज करना. दिस मशीन इज वेरी हेवी एंड दिस इज वेरी थिक पॉइंट. Okay, so you cannot use it. Now next thing is flux. Okay, so what is flux? What is flux, students? Students, what is flux? So this is the flux, students. Right, this one. Okay. So why is flux in soldering? This is not electrical flux phi. It is not that. Okay. This is a material. This is a gel type material. It's a rosin. Okay. So it is used in soldering. Why we use in soldering? We apply this flux to remove the oxidation of the surface, right? Okay. So what happens when we are doing the soldering? Okay, so our soldering iron provides very high heat, right? So due to that heat, oxides may come, right, in the surface. So due to these oxides, corrosion can happen, right? So to avoid this corrosion and to remove this oxide while doing the soldering, we need to apply this flux. Understood?
Yes, ma'am.
So you can check here. So soldering station we discussed, thermal master beds also discussed, tip of the iron coated to means soldering iron, right? Solder gun we also discussed. Flux we discussed. Flux remove oxide which arise during heating and is seen as brown fluid bubbling away on the joint. Flux is a solvent consisted of natural or synthetic reagents to remove oxides on the copper surface. Okay. So it is non-corrosive and non-conductive and will not affect the circuitry. Then temperature control. So what you need to do if you want to do a successful soldering, so whatever parts you are joining, you need to ensure that ensure that the temperature of all parts are raised to roughly the same level before applying solder. Okay. So melting point of most of the solder is in the region of 188 degrees centigrade. Okay, and the iron tip temperature is typically 330 to 350 degrees centigrade. So the latest lead-free solders typically require a high temperature, right? Then comes solder coverage. So already I discussed this part that you need to apply proper amount of solder, appropriate amount of solder. Okay, too much solder is also not a good idea, and also the too less solder is also bad for your soldering, right? So a few millimeter of solder wire is only required or enough for average PCB joint. Okay. So now there are some procedure for there's a procedure for effective soldering. So you can read these procedures. 10 points are there. So all parts must be clean and free from dirt and grease when you are doing the soldering. So before soldering, you need to ensure that all parts are clean and free from dirt and grease. Then try to secure the work firmly and tin the iron tip with a small amount of solder. Okay, do this immediately with new tip being used for the first time. Clean the tip of the hot soldering iron on a damp sponge. Many people add tiny amount of fresh solder to clean strip, right? Heat all parts of the joint with the iron for under a second or so. ओके सो अब ऐसा भी नहीं है कि ज़्यादा देर तक उसको अप्लाई नहीं कर सकते सोल्डरिंग आयरन को ज़्यादा देर तक भी नहीं वहाँ पे आप जॉइंट पे नहीं टच कर सकते आपको तुरंत हटाना होता है राइट बट फॉर 1 2 और 3 सेकेंड्स के लिए ही करना होता है ओके so continue heating and then apply sufficient solder to form an adequate joint. Remove and return the iron safely to its stand. It only takes 2 or 3 seconds at most to solder the average PCB joint. Do not move parts until the solder has cooled. Okay? जब तक solder cool नहीं हो जाता है तब तक parts को move नहीं करना otherwise joint ठीक से आपका नहीं होगा joint will not be proper. Okay? Now there are some do's and don'ts. What precautions you need to take when you are doing the soldering. Okay, So soldering iron should be kept on only when the soldering is being done. It should kept off when it is not used. Remember that when soldering, the fumes in the solder are harmful to your eyes and lungs. Therefore, always work in a well-ventilated area. Hot solder is also dangerous. Be sure not to let it splash around because it will burn you almost instantly. Eye protection is also advised, right? So what are the don'ts? Don't use a big soldering iron and the big 1x4 inch acid core. Anything higher in wattage like soldering guns will generate most of their heat by passing an electric current through a wire. Okay, so too big machine is also not required. So be careful not to apply your soldering iron for long periods of time. Otherwise, you can damage sensitive components or burn up a circuit headrest, right? Do not use too much solder and don't settle for a poor joint. If you have any doubt that your joint will not be proper, then immediately stop and resolder it. But if you solder the wrong joint, then again you need to do this desoldering and you need to again solder. Okay. These are some safety measures. So the tip is very hot, about 400 degrees centigrade. That can give you a nasty burn. You need to take care of this. Okay. So lead is a poisonous material, so you need to take care of that and always wash your hand after soldering. Okay, because everything you are working is very dangerous and poisonous also, right? Then comes desoldering techniques. So why we require desoldering techniques? So suppose you solder any component on PCB and your component is failed. Now you want to replace that component with other new component. So what you need to do? You need to first desolder. Means आपको उसे वापस निकालना पड़ेगा जो आपने soldering पहले से किया. Then you need to fix. Then secondly, अगर आपने कोई suppose wrong कंपोनेंट ज्वाइन कर दिया है तब भी आपको उसको डिसोल्डर करके निकालना पड़ेगा देन यू नीड टू then only you can again desolder for your component. Suppose you want to do the modification in your circuit. आपने कोई सर्किट बनाया अब आप मॉडिफाई करना चाहते हो तब भी आपको निकालने के लिए desoldering टेक्निक का यूज करना पड़ेगा. If suppose if other thing is that if suppose if board contains expensive component that can be salvaged, so in that case also you need to do the desoldering, right? So whatever is the reason, there are three common techniques to remove solder. First one is desoldering pump. You can use desoldering pump or sucker. Then second, desoldering bread or wick you can use. Then desoldering iron, right? So these are some desoldering techniques. So I will show you the video of soldering and desoldering also, so that you will get an idea how to do the soldering and how to do the desoldering, right? So first I'm sharing the video of soldering. Okay, how to do soldering. So students, we have already discussed what is PCB. I hope you understand what is PCB. We are talking about PCB almost since almost from 1.5 hours, right? तो मैंने आपको PCB बताया हुआ है क्या होता है. लास्ट एक्सपेरिमेंट जो हमने किया था फोर्थ वाला उसमें PCB पढ़ा था हमने, प्रिंटेड सर्किट बोर्ड, राइट? एक ग्रीन कलर का मैंने बोर्ड दिखाया था आपको, इस पे वो प्रिंटेड होता है, मतलब सर्किट आप ऑलरेडी दिस प्रिंटेड, यू नीड टू ओनली फिक्स द कंपोनेंट्स एज पर योर रिक्वायरमेंट, राइट? एंड तो कंपोनेंट फिक्स करने के लिए ऑब्वियसली यू नीड सोल्डरिंग, बट there are two techniques to fix the components. That is a hole technique and the surface mounting technique, right? In which you can use the surface mounted devices to, means you can directly fix, right? So I'm just sharing the video in which these two techniques are given, how to do the soldering for these two techniques. So link is provided to you in chat box, student. You can click on the link and can access the video. After that, we will discuss your doubts. The video is almost approximately of 5 minutes, right? So after 5 minutes, we will discuss your doubts. So please watch the video.
This video shows basic soldering technique and the equipment used to solder. There are two main types of soldering iron. The iron to the right has a station, which shows the temperature on the display. The controls adjust the desired target temperature. The one on the left works at a fixed temperature, but is used in the same way. If you're using a digital iron, then set the target temperature to around 350 degrees C, and wait for the iron to heat up. When you're not soldering, remember to keep the iron in the holder. Be careful when you're soldering not to put the iron in contact with the lead. Some soldering irons have PVC-coated leads which will melt through easily and pose a risk of electric shock if touched. The best leads to use are made from silicon, which won't melt at the temperatures soldering irons reach. The other item you'll need is, of course, solder. Solder is a low melting point alloy which flows easily when heated to its liquid state. When it cools and solidifies, it fuses to the surface of a metal at the molecular level, providing good electrical conductivity between two metal surfaces. Solder normally contains flux, which helps the solder to flow, and also helps make a good contact by removing the oxides on the surface of the metals being joined. Although modern flux is not toxic, when soldering you should always use a fume extractor to prevent the fumes from the flux irritating your lungs. The fumes are extracted by a high-efficiency particulate air filter, or HEPA filter, before the air is returned to the room. Before you handle the components, it's strongly advised that you wear an earthing band to prevent electrostatic damage to the components. There are two different soldering types, surface mount and through-hole. Surface mount connections are made by heating components with pre-applied solder in an oven so that it melts and joins to the surface of the board. For this tutorial, we'll look at plated through-hole soldering, which is done on boards with printed circuits on both sides. Through-hole soldering is when components are pushed through a hole in the board and soldered from the other side. The solder flows through the hole to make the best possible contact. First, take your component and create a bend in the legs with a pair of pliers, so that each leg is at a right angle. Push the legs through the holes in the board at the appropriate place and push it all the way down. Then turn the board over and bend the legs slightly to lock the component in place. When the iron is up to temperature, first clean the tip of the iron on the wet sponge on the iron holder to remove any excess solder and flux residue that might be there. You then apply heat directly to the pad for about a second before placing the solder in contact with the pad. When the solder starts to melt, feed it in for about a second. Take the solder away, but leave the iron on the pad for another second. Then take the iron away and let the connection cool. Let's have another look at that. Before you make another connection, it's important to remove any excess solder remaining on the tip of the iron. This is because any flux in the solder will vaporize until there's none remaining. If you try to make a connection with solder without any flux in it, you risk making a bad connection. When you turn the board over, you should see that the solder has flowed through the hole by capillary action, guaranteeing a good contact. Trim the leads just above the solder using some wire cutters. When you cut the wires, be careful that the cut end is held captive so that it doesn't fly off. This can be done by putting your finger on the end when cutting. If you make a bad joint or want to remove a component, you can remove the solder by using a desoldering pump. This is a spring-loaded piston with a trigger, which when released creates a vacuum which sucks the solder up. Cock the pump. Use the iron to melt the connection and put the tip of the pump onto the melted solder, then release the trigger. You might have to repeat the operation several times to clear all of the solder. An ideal solder should look like a cone with slightly concave sides, showing that the solder has flowed through the hole. You can see all the solders here look regular. Bad joints are noticeably different to the concave cones of good joints. If your joint looks like any of these, then it'd be wise to remake it. Bad joints can lead to intermittent connections, or no connection at all.
This is a video that I've wanted to make for a long time. A lot of the projects that I show on this channel involve some
Yes, finished, students? Okay. So, any doubt in this? Any doubt, students? Okay, now coming to the desoldering technique. So we can use the desoldering pump. Okay, this is desoldering pump, and also we can use the desoldering wick. Or bread. Okay, and this is how we can apply this brick. Okay, and this is the iron. Now I'm sharing one video of desoldering techniques. It is of 3 to 4 minutes video. You please watch that. After that, we will discuss your doubts. So it is approximately 4-minute video. So in this video, all the desoldering techniques are discussed. Okay. Means all the desoldering techniques are shown in this video. You can watch it. The link is pasted, student, in chat box. You please go through that link. Yes, done, students. Yes, I hope you understood that what is desoldering and what are the techniques available how to desolder a component, right? Any doubt? So A is completed. So aim B is that you need to design a circuit, right? You need to design a circuit on PCB by soldering. But this is online lab, so I will give you a circuit. I will give you the name of the circuit. You need to design, means you need to draw the circuit diagram of that circuit. You need to find the circuit diagram and you need to draw it in the lab manual, and then you need to make a table of components in which you will write all the components and its details, specifications, right? So okay, so here it is written. Student will carry out a small circuit based project. Firstly, it should be checked on breadboard, but right now we don't have the offline laboratory, right? So I will provide you the circuit. You need to draw the detailed circuit diagram and you need to write all the components details. That's it. Okay. It will be available on LMS. You regularly check your LMS. I will not share any lab manual on mail. Mail sharing is not required. Everything is available on LMS, and you will be able to see this experiment PDF. Please regularly check your LMS, right? Deadline is also there. अभी नहीं दिख रहा है आपको एक्सपेरिमेंट तो कोई बात नहीं, अभी थोड़े दिन रुक जाइए, 2-3 दिन बाद वो ओपन हो जाएगा. Okay, and deadline also will be given to you to submit, right? Any doubt?
No,
And
ma'am.
on next turn we will do the assessment for experiment 4 and 5, because our experiment 4 5 today we have completed these experiment, right? So on the next session there will be the assessment of 4th and 5th experiment. Fine. Okay, so if no query, no doubt, you can all leave the meeting. Thank you.